Okay, let's start. We want to solve this type of equation. We want to solve rational inequalities. This makes it a little bit more difficult. So we'll see what we get. So here's the example problem. We're going to try to solve x is less than or equal to 2 over x minus 1. You need a scratch sheet of paper. I don't have notes for you. Yeah, I did that front. What? I did 1.7 inequalities. Yep. What, were you gone yesterday? Did you watch my video? So if I check up on you on a Friday night at 11 o'clock, what are you gonna be doing? Yeah, right. You're gonna be at Sarah's house, painting your nails, telling stories. You don't paint nails. You guys are girly girls. All right, here we go. So first step with a rational inequality is you set it equal to 0. Okay? So let's perform that first step. What should I do here? Subtract the x over, thank you. 0 less than or equal to 2 over x minus 1 minus x. Second step is to make into one fraction. If you want to make it one fraction, what do you got to do? Common denominators, Billy Barbers. Super smart. Multiply top by x minus 1, bottom by x minus 1. Beautiful. So that's going to give me 0 is less than or equal to. What am I going to have in the denominator? X minus 1. Great job, Casey Gilbertson. What am I going to have in the top? Two minus x squared plus x, right? Because we have to distribute the negative x to the x and the negative x to the negative 1. Right? So that's my new expression. That is one fraction. Third step. Set top equal to 0. Set bottom equal to 0. Solve each. Now everybody just hold on real quick, okay? Everybody, we'll let you get that down. Anytime you have a rational expression, there's problems that come up. And so I want to bring your attention to this right away. As you look at this rational expression, what number can you never divide by? 0. So what number would you plug in for x to make 0 in the denominator? 1. So just a note, x cannot equal 1. That is not in the domain. All right, we're going to turn back to that in a little while. So I guess at the top equals 0, bottom equals 0, and solve. And the way I do that is, through factoring, if we can. So I get 0 is less than or equal to. If you want to try to factor that top, and this does factor, what would you take out first? Oh, negative. Very good. Negative. We'll have to positive x squared minus x minus 2. All over on the bottom, x minus 1. 0 less than or equal to negative parentheses, what's top? Good. X minus 2, x plus 1, x minus 1 on the bottom. So if I set all of these equal to 0, the top and the bottom, what values for x will give you 0 on the top? Right, so 2, negative 1, and then the bottom, 1. Now, let me help you understand why we're doing this. So let's just relax for a second, and we'll pay attention here, okay? 0 is really a dividing line. In fact, the number 0 was never actually thought to be a number until, many, many years later, after many mathematics had already been done. And the concept of 0 is developed by the Mayans. And this idea of 0 is really the absence of value. So the 0 divides numbers into two categories. What two categories? Positive and negative. So these that satisfy 0 are the dividing points. When we're dealing with inequalities, we are always wondering where are things positive or where are things negative. These are the spots where that tilts to one side or the other. These are the dividing points. And so these are the points that we're very concerned about. Now, here's the other thing you have to be aware of. This piece factored up top there, but they might not always factor. Let me give you one example. Let's suppose that you ended up with this. X squared plus 5 over x minus 3. Okay? Greater than 0. Great. Well, what number gives you 0 on the bottom? 3. What number gives you 0 on the top? Nothing. In fact, x squared plus 5. If you subtract the 5 over and square it both sides, you come up with what type of a solution? Right? So you see in this situation, you get imaginary if you set equals 0. Well, just think about this for a second. If you square a number and add 5 to it, it could be positive or negative. Give me a number. 5. 5 squared is 25 plus 5 is 30. Give me another number. How about negative 2? Negative 2 squared is 4 plus 5 is 9. Any number you plug in, you're going to get a positive result. So you know that this piece is just going to be positive. So sometimes the rules and the processes which we give you in mathematics, you need to be able to think through the actual problem. This can never be negative. It can never be negative unless you use imaginary numbers. So it doesn't even need to be factored. You just know the top is always, always, always positive. And that's something that we use. So let's try to finish this part off. We have our interesting numbers. The fourth step is make a table. And when I make my table, I put those interesting points at the top of my divisions. I'm going to make a big table here. A lot of times people make their tables too small. I err on the side of too big. So, these are the spots where it divides. These are the spots where it might fall from positive to negative. So I have to put these numbers on top. Which number should I put first? Negative 1. Then 1. Then 2. We got that right there. Great. Then over here, I put all my factors. All right? So we could have one factor of x minus 2. We could have another factor of x plus 1. We could have another factor of x minus 1. Do we have another factor? That's your -1, don't we? Is that negative going to change the value of the function? It sure will. So we need to account for that. So I've made my chart. Now we just start plugging in values. What's a number to the left of -1 that you could plug in? -2. What's a number between -1 and 1? 0. Between 1 and 2? 1 and 1/2. Past 2. So I'm going to try to plug in those numbers and see what happens. If I plug in -2, -2 minus 2 is negative. -2 plus 1? Negative. -2 minus 1? Negative. Can I plug in -2 anywhere down here? No. -1 is just always negative. What if I plug in 0? 0 minus 2? Negative. 0 plus 1? Positive. 0 minus 1? Negative. And -1 is always negative. 1.5 minus 2? Negative. 1.5 plus 1? Positive. 1.5 minus 1? Positive. And -1 is always negative. I do my last one. 3 minus 2? Positive. 3 plus 1? Positive. 3 minus 1? Positive. And -1 is always negative. Hey, Christian. So now it's time to, all these factors, what was our original problem say? -1 times x plus 1 times x minus 2 divided by x minus 1. So if these are the values that come out, we're just multiplying and dividing them. So 4 negatives is going to give me positive. 3 negatives and a positive? Negative. 2 negatives, 2 positives? Positive. And 1 negative and 3 positives? Negative. So the fifth and final step is this. Solve. What are we trying to decide? Are we trying to wonder if this function is positive, or are we trying to wonder if it's negative? The original problem, after we subtract the x over, is 2 over x minus 1 minus x is greater than or equal to 0. So we're wondering where it's positive. Where is it positive? Well, it says it's positive in this interval right here. How would you express that? For x values less than or equal to -1, right? Or this middle section right here. X between 1 and 2. Now, why did I use the equal signs on these? Because that's what my original problem used, right? But what can x not equal? 1. In my final solution, do I have that x could equal 1? I do. So one last piece I have to do is take off that equal sign. So I checked for where I could get 0 in the denominator. Very small, subtle change. That has to happen. That's my final solution set. I did it by using a table. That's the type of problem you want to be able to do. Let me pause this. I'm going to put your assignment on the board. You have the. So this is your assignment. These first ones are just linear. They're easy. That's like stuff you did back in Algebra 1. And then this middle section, that's quadratic, which you did last year, but then you also have some of the rational stuff that we just did. And then 57 through 65, those are absolute value ones. We'll practice that at the beginning of class tomorrow. You're also going to get some time to work tomorrow. Remember, when's your homework test due? Monday. Switch it to Monday. Riz, Savvy, Monday homework test is due. Whoa! Did you ask your bus driver for help? That would be cheating. Liar. All right, there you go.